Before we address confidence intervals for population variance and standard deviation, we must first get to know the chi-square probability distribution. Assume that we're interested in a quantity that is described with a random variable y, which follows a normal distribution with population variance sigma squared. For example, y could represent the weight of soda cans filled using a particular piece of bottling equipment. We pull a sample of size n, y1 through yn, from the population. It has been empirically demonstrated that ratio n minus 1 times s squared divided by sigma squared follows a particular probability distribution based on the size of n. This probability distribution is the chi-square distribution. Like the t-distribution, there is one parameter that governs the shape of the chi-square distribution, the degrees of freedom. For our purposes, degrees of freedom is n minus 1. The larger the value of degrees of freedom, the flatter the distribution. Unlike the normal, standard normal, and t-distributions, the chi-square distribution is not symmetric and is skewed to the right. Further, the values on the chi-square distribution axis can never be negative. As the chi-square distribution is not symmetric, looking up values on the chi-square axis requires a little more work than the z or t distribution. For example, with the t-distribution, if we want to find plus and minus t 19.025, or a value of t with degrees of freedom of 19 associated with alpha over 2 of 0.025 in each tail, we find the upper tail value in the lookup table, and we automatically find the lower tail value with the negative of the upper tail value. In this example, t for degrees of freedom 19 with 0.025 in the upper tail is 2.093, therefore negative t, degrees of freedom 19, 0.025, is negative 2.093. With the chi-square distribution, most textbooks provide the upper tail value with typical options like 0.1, 0.05, 0.025, 0.01, and 0.005. But they also provide a complement of each of these, 0.9, 0.95, 0.975, 0.99, and 0.995, to allow us to look up lower tail values. For example, alpha over 2 of 0.025 in the lower tail corresponds to 1 minus alpha over 2 of 0.975 in the upper tail. If we need a 99% confidence interval when we have degrees of freedom equals to 12, we must look up chi-square for degrees of freedom 12, 0.005 for the upper tail, and chi-square for degrees of freedom 12, 0.995 for the lower tail. Using a lookup table, chi-square 12.005 is 28.3, and chi-square of 12.995 is 3.074. Much like the t-distribution, we should round down if the lookup table we're using doesn't provide the exact degrees of freedom we need.